Hi guys, now we continue chapter 1 for week 1. Chapter 1, Physical Properties and Classification of Soil, week 2. This is the program outcomes, PO1 and PO2. COPO already discussed in the previous lecture. So now we go for the learning outcomes. Okay, at the end of the lecture, students should be able to understand engineering, definition of soil, the constituent of soil, solid, liquid and gas phases, mineral particle, water and air. Okay, basic physical properties of soil and three-phase diagram, including volume relation, mass relation and mass volume relations. And number 2, determination of moisture content and particle density of soil solid. Firstly, we go for the engineering definition of soil. Soil is uncemented deposit of minerals and organic particles or fragments covering large portion of the earth crust. To an engineer, soil is a material can be built on, built in, built with, and supported. Okay, for example, built on foundation of buildings and bridges. It can build in basement, culvert, tunnels, built with embankment, roads, dam, and can be supported by using the retaining walls. Alright student, look at this. This is constituents of soils. You should know that the soil consists of solid, liquid and gas, which is liquid is water, gas is air. Soil commonly consists of mixture of inorganic material, particles, water and air. Therefore, it is convenient to think of soil model which has three phases: solid, liquid and gas. Okay, if you see here, this one is solid particles and then you have void. In the void, it will consist of air or water or air and water. Alright, so we have gas, liquid and solid. For example, gas is air, water, vapor. Liquid, water or dissolved salts. For solid, it may consist of rock fragments, mineral grains, organic matters. Okay, this is the three-phase diagram soil model. Firstly, we start with solid. Rock fragment. Okay, rock fragment usually more than 2 mm in size. For example, sand to gravel. And mineral grain, the spread particle of each particular mineral and range size from more than 2 mm to 1 mm. Okay, soil will consist maybe one minerals, or some soil will contain mixture of different minerals. Alright, so soil fabric. Okay, during deposition, the mineral particles are arranged into structural frameworks that we call soil fabric. Each particle is random contact with neighboring particles. Two common types of soil fabric is flocculated and dispersed. You may also refer to this YouTube website. Another solid is clay minerals. Minerals are crystalline materials and make up of solid constituent of soil. Mineral can classify according to chemical composition and structure. Okay, now continue to liquid. For example, water. Water is a part of natural soil. It has greater effect on engineering properties. So it's related to compressibility, seepage, and permeability. For your information, water has no strength, but relatively incompressible. So means that we cannot compress it. Hence, it transmits direct pressure. Therefore, drainage conditions in soil mass are a great significant when considering shear strength. Okay. Alright, surface force and absorb water. Okay, because of the large surface area of fine-grained soil, surface forces significantly influence their behavior compared to coarse-grained soil. Okay, so means that for small or fine-grained soil versus coarse-grained soil, fine-grained soil have a larger surface area. The clay-water interaction coupled with a large surface areas result in clay having larger water holding capacity in a large number of smaller pore spaces compared with coarse-grained soil. Now we go to third element for soil, which is gas. Okay, we have solid, water and gas. Okay, gas is air. Air is compressible and water vapor can freeze. So may be considered to be perfectly dry or fully saturated, or in the condition somewhere between these two extremes, which is partly saturated. In dry soil, water vapor is present, while fully saturated so may contain as much as 2% of air voids. So means that, as you know that we have surface diagram, we have solid, water and air. Okay, for the condition for perfectly dry, we only have solid and also air. For condition fully saturated, we only have part water and also solid. So that is the difference between dry, fully saturated and also partially saturated. Because partially saturated, we have air, water and solid. As you know that soil consists of solid, water and air. So this one is a unit solid volume model. Okay, this one we have air, water, solid, volume air, volume water, volume solid. You can refer here. And for your information, volume solid is equal to 1, which is 1 meter cube of solid materials. Okay, refer to this model. We have 1, 2 and 3 models. So what is the difference? Okay, so for the model, if you notice here, we have to remain constant for solid is equal to 1. So for air plus water is equal to E. E is void. Alright, so void consists of air and water. Okay, for this condition is no water, so means that we only have solid and also air and air. So solid and air. So this one is we call as fully dry. Okay, if you have air, water and solid, partially dry. Okay, for this one, we only have solid and water. So there's no air. So this one we call as the fully saturated. So this one is three-phase diagram. This one is two-phase diagram. And this one is two-phase diagram. This is the difference between fully saturated and fully dry. Alright, now we go for mass volume relationship. This one is volume. This one is mass. Okay, for total mass, total mass is equal to mass solid plus mass water plus mass air. But mass air is equal to 0. So mass total is equal to ms plus m water. Okay, for total volume, V total is equal to Vs plus V water plus Va. So it's equal to 1 plus E, because Va plus V water is E, which is void. Okay, now we continue mass volume relationship of soil. Okay, this one is mass, this one is volumes. So mass, and we have mass air, mass water and mass solid. So mass air is equal to 0, mass water is moisture content in percentage times GS times raw water. Raw water is equal to 1000 kg per meter cube or 1 mg per meter cube. GS is specific gravity. This depends on type of soil. Alright, so mass of soil, MS, is equal to GS times raw water. This one is about mass. Now we go for the volume. So this one is you have to remember the diagram and the equation. Volume air is equal to E times 1 minus SR. Okay. Volume water is equal to SRE. SRE is equal to WGS or MGS. W is moisture content. Alright. VS, as we mentioned before, VS is equal to 1. Alright, so how 1 plus E come out? So we have 1 plus E here. So because E times 1 minus SR, so E minus SRE. So E minus SRE plus SRE, it become E. Okay, that's why this one is E. Alright. Void ratio, porosity, and specific volume. This one is related to volume. Yeah. The volume not occupied by solid, known as void volume, may occupied by water or air or both. Okay, if you still remember, we have air, water, and solid. This one is void. Okay, so to determine the value of void ratio is equal to volume of void over volume of solid. So volume of void is VA plus V water divided by Vs. So VA plus V water is equal to E. Vs is 1. So void ratio E is equal to E. Alright. So porosity, the expressing of the quantity of void. Okay. So N is equal to volume of void over total volume. Okay. Total volume is this one. Total volume is 1 plus E. So volume of void is VA plus V water, which is E. So E over 1 plus E. So porosity is equal to E over 1 plus E. Okay. Specific volume. The total volume of the soil model, which is V is equal to 1 plus E. This one lah. Alright. Okay, now we go for the degree of saturation, SR. Measure how saturated the soil is. For the degree of saturation, we have perfectly dry soil, which is SR is equal to 0%. And we also have the fully saturated, which is SR is 100% or 1. Okay, so how to determine the degree of saturation? Degree of saturation is equal to volume of water over volume of void. Okay, as you know that volume of void is consist of volume of water plus volume of air. Alright, so it's equal to E. So volume of water is V water over E. So V water is equal to SRE. So SR is equal to V water over E. Alright, so how about air void ratio, AV, ratio of air void volume to specific volume. Okay, so we want to know how much is the air volume. Okay, so when we're talking about the air void ratio, so AV is equal to volume of air over total volume. Volume air is equal to E times 1 minus SR. Total volume is 1 plus E. So this is equation for air void ratio. Okay, however, we also have another equation for air void ratio. If we want to use the moisture content and GS, you don't want to use the degree of saturation. SR is equal to WGS over E. Okay, if you remember in the surface diagram, SRE is equal to WGS. Okay, so SR is equal to WGS over E. So, okay, from the equation here, you just insert the value of SR here as WGS over E. So here, look at this. E minus E times WGS over E over 1 plus E. So you will get the equation AV is equal to E minus WGS over 1 plus E. Specific gravity, ratio of mass of given volume of a material to the mass of the same volume of water. So GS is equal to mass S over Vs over raw water. Right? So moisture content ratio of mass of water to mass of solid. So means that M water over M solid. So this is the equation M GS raw water over GS raw water. So it's become W. Alright, so therefore W is equal to SRE over GS. Alright, or WGS raw water over GS raw water. Alright, so dry density in unit kg per meter cube or mg per meter cube. So dry density is equal to mass of solid over total volume. So ms over volume. So if you remember in the soil paste diagram, ms is raw water gs. Okay, volume is 1 plus E. So this is the equation for dry density. How about the bulk density? Bulk density means that total mass. So including mass of solid and water, because mass of air is equal to 0. So we not consider the mass of air. So roll bulk is equal to mass of solid plus mass of water divided by total volume. So mass of solid is roll water Gs plus mass of water is water content raw water Gs over 1 plus E. So you may use this equation or you also can use this equation. The difference is, if you still remember, SRE is equal to MGS or WGS. So this one is WGS. So here W and GS. So SRE is equal to WGS. So we change to SRE. So the equation become roll bulk is equal to roll water times Gs plus SRE over 1 plus E. So you may use this equation or this equation. It depends on the information that you have. Okay, this one is relationship between bulk density, roll bulk, and dry density, roll dry, roll D. Okay, roll bulk over roll dry is equal to roll water Gs plus W roll water Gs over 1 plus E. This one is roll bulk. Roll dry is roll water Gs over 1 plus E. So roll water Gs times 1 plus W, because we put the roll water and Gs outside, then it's become 1 plus W over 1 plus E. So this one is roll 1 plus E added up, roll water Gs bottom. So we will slash this one, and slash 1 plus E and 1 plus E. So you only have roll bulk over roll dry is equal to 1 plus W. Okay, so roll bulk over roll dry is 1 plus W. So roll bulk is equal to 1 plus W times roll dry, or roll dry is equal to roll bulk over 1 plus W. Okay, now we go for the saturated density. For information, saturated density is related to the bulk density. The difference is, for bulk density, that one is for partially saturated. For fully saturated, we call as the saturated. Okay, saturated density. Alright, so for saturated density, SR is equal to 1 because 100%. So roll bulk become saturated. So the equation for roll bulk, roll water Gs plus water moisture content roll water Gs over 1 plus E. So roll bulk is this equation because WGS is SRE. So this one is SRE times roll water, you see here. And then we want to change to roll saturated. SR is equal to 1. So SR here is 1. So roll water Gs plus E roll water over 1 plus E. So this is the new equation, which is what you do is you put the roll water outside. So you have Gs plus E over 1 plus E. Alright, this one is submerged density or effective density, roll sub or roll effective in unit mg per meter cube or kg per meter cube. Okay, so if in kg it become 1000, okay, 2000 plus 1000 plus. For in mg it's become 1 point something or 2 point something. So roll effective or roll sub is equal to roll saturated minus roll water. Roll water is 9.81. So if you choose the roll water is 9.81, so this one roll saturated should be maybe roll saturated is 19 mg per meter cube, for example, minus 9.81. So you will get the roll submerged or roll effective. Okay, this is equation for unit weight. Unit weight is equal to roll times G. So for example, unit weight for bulk. So roll bulk times G. G is 9.81. So unit weight for dry. So roll dry times G. Unit weight for fully saturated. So roll saturated times G. That is how to determine the unit weight. Determination of specific gravity or particle density. For fine soil, we use the density bottles. For coarse soil, we use a gas jar or gas jar fitted with conical screw top. Okay, this is how the procedure is being done. Okay, you may refer here. Okay, this is determination of specific gravity. You may refer to the equation here. Okay, so how to determine the specific gravity. Okay, this one is for example 1. Soil having void ratio is E 0.75 and percentage of saturation of 85%. So meaning that SR is equal to 85%. Determine the porosity and air void ratio. Okay, so porosity is E over 1 plus E. So we have void ratio here 0.75. So this is the value for porosity, which is 0.429. We're using this equation. Air void ratio, AV, is equal to E times 1 minus SR over 1 plus E. So SR is equal to 85%, so 0.85. So AV is 0.429 times 1 minus 0.85. So what is the answer? Okay, this one is another example. Okay, we see here this one is we have a mass of the moist soil. So means that bulk. Okay, 37.82 gram. The empty mass is 16.15. After drying, soil was weighed again and had mass 34.68. So means that this one is dry. And then determine the void ratio of soil if the air void content is 0 and air void content is 5%. So first is you have to determine the water content. So water content is mass of water over mass of dry soil. So mass of water is 37.82 minus 34.68. Okay, so you will get mass of water. And then mass of dry soil is 34.68. Remember, you have the empty thing here, 16.15. So you will get 0.169 or 16.9%. Okay, so that one is water content. Okay, void ratio content is 0. SR is equal to 1. E is equal to MGS, WGS. So 0.169 times 2.7. So you will get E is 0.456. So if the air void content is 5%, so AV is 0.05. So you are going to use this equation. So moisture content is 0.169 times 0 times 2.7 plus air void is 5%, 5 over 100, 0.05 divided by 1 minus AV, 1 minus 0.05. So you will get 0.95. So the answer is 0.533. Okay, this one is another example. You may refer here. Alright. So you do by yourself. Okay, this is another example 4. So you may refer by yourself and then you have to do the calculation. If you have any question, you may ask. Alright. Alright, this one is another example. Okay. Okay, you may read the question here, and the question here asking you to determine the part density, moisture content, dry unit weight, void ratio, saturated density, and percentage of air void. Right, so the answer will be shown in the next slide. So you have to do by yourself first, and then after that you can check the answer. If you don't have any question, it's okay. If you have any question, you may ask. Okay, this is the solution for question example 5. Okay, you may check here. Alright, so if you have any question, you may ask. If you don't have, it's okay. Okay guys, I hope that you can do exercise all the 5 example here, and then you can check the reference book from the Whitlow or DAS. There are a lot of example, and then you can do by yourself, by your own, the exercise from the past years. Remember, success is not accident. It is hard work, perseverance, learning, studying, sacrifice, and most of all, love of what you are doing or learning to do. Good luck, guys.